addressing carbon pollution state by state in the U.S. As you probably know, earlier this month, a stay was granted by the Supreme Court, temporarily halting the implementation of the Clean Power Plan along its previously anticipated timeline. However, many states continue developing their individual state implementation plans, and the need for information and clarity regarding this policy remains, so our webinar series continues in an attempt to explore the role of renewables, especially bioenergy, in the state-level plans being designed right now. The goal of this webinar series is to take stock of what we know, what opportunities this policy opens nationally and locally, what information from recent literature should enter this topic of conversation, how we can conduct fair and balanced advocacy on behalf of the industry in which we study and work, and what uncertainties stakeholders in the bioeconomy face when engaging on this topic. At this point, I want to make a note about a recently announced open EPA workshop for stakeholders at the intersection of CPP state implementation plans and biomass. This is a free workshop to be held on April 7th from 9 a.m. to 5 p.m. that can be attended in person. The workshop will be an excellent opportunity to receive input and clarification directly from the EPA on the complex issues we're all navigating on this subject. Registration information can be found via the link in the chat pod to the left or in the notes for the recording. Today's presentation, to which I'm pleased to welcome you all, is the third in our new webinar series, as I said. Our first presentation gave an overview of the context for American carbon policy and biomass in the Clean Power Plan, and our second initiated the current arc focused on carbon accounting. Both of those presentations are available as recordings on the series webpage for free viewing, along with a longer series schedule detailing future presentations in this series. That webpage URL can also be found linked in the chat pod to the left or in the notes for the recording. Our next presentation brings us to the arena of CPP market effects with speaker Greg Latta of Oregon State University on March 8th at 1 p.m. Eastern. Again, all webinar sessions will be recorded and released on YouTube to allow later viewing and sharing via the series webpage. During today's presentation, feel free to type your questions directly into the chat pod on the left and set aside some time at the end to go through more complex topics with our speaker. The presentation's accounting for biomass under the Clean Power Plan. It's presented by EMcGlynn, who serves as a senior advisor at Forest Trends, an international NGO focused on opportunities for markets and private finance to preserve and grow the world's forests. Formerly as Director of Strategy and Policy for the Earth Partners, she led on advisory services, sustainability, policy analysis, and entry into new markets. Previously, Emily also served as a senior advisor to the Special Envoy for Climate Change at the U.S. Department of State, leading on high-priority international initiatives to reduce greenhouse gas emissions. She also served as a transatlantic fellow at Ecologic Institute and TU Berlin in Germany, developing policy recommendations for the European Commission and other public and private sector stakeholders on carbon markets, transportation policy, and other issues. Emily has a background in ecology and economics from Bryn Mawr College and Johns Hopkins University. She brings this extensive experience to our webinar series today to continue the conversation on biogenic carbon accounting and the place of bioenergy in the Clean Power Plan. It's truly a privilege to welcome her to this series.
Thanks, Sarah. Can everybody hear me okay? Hopefully it's still working. Thanks a lot for having me here today. Thanks, Sarah, for that really nice introduction. I'm really excited to be speaking at this point in the series because a lot of exciting things have happened in the past couple weeks and very relevant to this issue. So I'm the lucky one who gets to kind of reflect on all of these interesting things, some good, some bad. But let's look ahead to the future and see what it means for biomass in the United States. So what I'd like to cover today is just taking a step back, looking at what the stay means, the Supreme Court stay means for the Clean Power Plan, and particularly for biomass, because I think for some components of the Clean Power Plan, the stay and the future legal challenges might have different outcomes for different pieces. Looking at that EPA has gone through over the past 5 years now to try to come to consensus on how to handle emissions from biomass, what they're calling biogenic emissions, looking at what other stakeholders do, and then trying to think about what does this all mean, and how will this issue be finalized in new regulation, and particularly in the Clean Power Plan. Trying to leave plenty of time for questions and conversation at the end. And please, if folks want to stop me at any point and ask for clarity, and Sarah, if you want to flag, if there's clarifying questions throughout, let me know. So, what just happened? Well, there's been about a 6-month timeline since the legal challenges have started with the Clean Power Plan. As soon as EPA formally published the final Clean Power Plan rule in the Federal Register, 27 states and a number of industry players filed suit against the rule with the DC Circuit Court of Appeals, asking for the courts to stay the rule, not allowing EPA to require any work to be done against their timeline until the courts had weighed in on the legality. Relatively quickly, the DC Circuit Court denied the stay. That was back in January, and so the 27 states and others immediately appealed that. The court decision also turned around pretty quickly, and just a couple weeks ago, February 9th, the Supreme Court decided against all precedent that even before any of the legal merits of the rule had been discussed by the lower courts, they were going to stay the rule. That was a big shock, I think, from folks that I spoke to in the administration. This was a big disappointment and very surprising for them. The fallout has been mixed. I continue to see commentary from states who say they do plan to continue, states like California, sometimes within states. And different agencies within the government. So a lot of different interpretations of what this stay means for the timelines of the states and how they continue or don't continue their state implementation planning processes. That said, there's many folks in the power sector that I'm aware of that continue to plow ahead and want to understand what their mitigation strategy will be under this type of regulation. It's been likened in some commentary as the genie's been let out of the bottle. There's really no way to go back to a time when power utilities and the coal sector and others feel safe in terms of not having to face any new regulation on these lines, along these lines. So I think in general you're going to continue to see some movement, which is good and important for the rest of this conversation. The rest of the timeline for how this gets worked out in the courts, DC Circuit Court has already decided to expedite their considerations on the actual substantive legal arguments against the Clean Power, move fairly quickly to coming to a decision, could be as soon as late summer, by the time we get a DC Circuit ruling. Given the composition of the DC Circuit, it's likely that the Clean Power Plan could come out on the other side of that unscathed. And then following that, it would be appealed to the Supreme Court, which of course now is incomplete with a likely 4-4 composition of 4 justices for, 4 justices against, in which case the case would revert back to the district court ruling, the lower court ruling. So all of this is to say that the legal standing of the rule, I think there's room for optimism at this point. what that means for what the stay does to the whole timeline of this process. It's too early to say concretely, but I think my gut tells me that EPA's timeline for implementation of the Clean Power Plan was the 2022 timeline for full implementation of the Clean Power Plan is still likely to stay in place. I think the administration was expecting there to be these kinds of legal delays. So I would say it's positive that we're going to be moving forward along at least a similar timeline to what was originally expected. So what are the legal challenges currently in front of the district circuit? First of all, there's kind of four key buckets of challenges. First, that EPA doesn't have the legal authority under the Clean Air Act to regulate power producing facilities outside the fence line. They can't require coal plants to somehow utilize new renewable energy installations to count against their own emissions, which is the third building block of the Clean Power Plan. That kind of argument. Second argument, can't regulate sources of emissions that are already regulated under Section 112 of the Clean Air Act. Fossil fuel power plants are already regulated under Section 112 through the mercury and air toxics rule that was just fully came into play, I guess that was last year, after a bunch of legal action as well. So that's a little bit more of an administrative and unclear how the courts are going to read that issue. The other argument is that the EPA is overstepping their legal boundaries in terms of how much they can overstep states' authorities in regulating the power sector. And then there's a number of administrative challenges that indicate EPA did not follow the correct process for finalizing the rule and following the letter of how they're meant to develop the best system of emissions reduction for regulating the power sector. So all of those challenges, there's different ways depending on which challenges are supported by the court. If one or more of them ultimately do come into play as requiring EPA to go back to the drawing table and modify some of the approaches under the Clean Power Plan, there's still some scenarios there where be an important component of the effort to reduce emissions from the power sector, especially if there's concern about outside the fence line requirements, particularly for biomass co-firing. That would still very much be a legally safe mitigation strategy forward under the Clean Power Plan, even with a truncated Clean Power Plan where some of the building blocks end up being thrown out on legal grounds. Biomass co-firing is a relatively attractive mitigation option as well. Just comparing it on a dollar per ton CO2 reduced basis to other options that coal plants will face, a low-level biomass co-firing rate of 10% is, under some scenarios, even more cost-effective than natural gas redispatching. Could be cheaper than a total natural gas repowering scenario where you have a coal plant that's shifting and reconstructing their boiler to be able to utilize natural gas. So I think it's going to be an important option that coal plants consider. Here in the U.S., it's not as well understood as, for example, in Europe, where biomass co-firing is quite common. But I think more and more coal plants, especially, are going to be looking at this, both this I think probably the new build biomass is going to be less of an attractive option under the Clean Power Plan. That's a much more expensive outlet for utilizing biomass. But in my mind, I think the biomass co-firing is both economically a potentially very attractive mitigation option, and also legally, I think it's going to stand the test of time. So I think we're going to see biomass continuing to play an important role. I have a question. What's the difference between column 1 and column 3? Oh, so these are just two different estimates. The third column was the cost estimate that EPA included in their technical support documents for the Clean Power Plan rule. That's their estimate of the mitigation cost of using a 10% biomass co-fire. With some research that I did, I came up with a slightly lower cost, but it's likely to be somewhere in that range. Okay. Okay, well, sorry, one more question. Natural gas redispatch. Sorry. Sorry, we're having competing. Building block of the Clean Power Plan, where essentially EPA is hoping natural gas capacity will be utilized more heavily so that coal base load power can be decreased, and on balance you end up having a lower carbon intensity on the grid. Dedicated in column 2 means 100% use of biomass. No blending with coal. All right. We can also come back to this. It's a little bit of a dense figure, and I think, Sarah, we can share slides with folks if they'd like that. So EPA does speak to the role of biomass in the final rule. This is something that probably other folks on the other webinars have spoken to. Biomass co-firing in particular, which is recognized as a possible mitigation strategy that states can include in their state implementation plans. So I think for folks interested in biomass markets, that was a very positive development in the final rule. It was not mentioned explicitly in the draft rule. But EPA was very careful to indicate that only qualified biomass will be eligible for inclusion in state implementation plans, but was also left the door open to provide a more explicit explanation of what qualified biomass actually means. They want it to mean any type of biomass that can demonstrate net CO2 reductions compared to a fossil fuel baseline. So how do you demonstrate that biomass is quote-unquote qualified? That's the real question, and that's what we'll try. EPA did give some initial indications of what they would like to see. They said waste and industrial residue types of biomass are very likely to be considered biomass from sustainably managed lands may be considered qualified. However, they don't go into any explanation about what sustainably managed means necessarily. And they indicated that their work on this biogenic emissions assessment framework would be very important, for informing what qualified biomass is, but that states will also have flexibility in creating their own frameworks for determining what qualified biomass is. But they do need some sort of framework in place to determine what's qualified and what's not. It's pretty clear that that has to be a component of the state plans. EPA indicated that they would review each state's proposal for how to handle qualified biomass on a case-by-case basis. So a number of folks have been concerned that that potentially leaves a pretty long time for uncertainty about what an acceptable qualified biomass framework actually looks like. State plan to understand that, and given the looseness of the requirements that EPA has included in the final rule, I think that's this should definitely be a priority for the industry to try to get some consensus around this issue so that states are able to plan and have confidence. So let's talk about this. Let's talk about what qualified biomass could mean, because this can get to be a pretty wonky issue, but when it comes down to it, it's probably going to be the most important thing that drives the value of biomass under the Clean Power Plan. If the U.S. is interested in developing new biomass markets, the carbon accounting for biomass is going to be a huge issue. So that's what we want to talk about. The science has been developing in a really interesting way around this issue. I think of this in his presentation last time. There's a number of issues that need to be taken into account in order to represent the latest science. Baselines to use. You need to understand what would have happened to that biomass otherwise if it hadn't been used for bioenergy, to understand whether it's creating a net positive emissions into the atmosphere. You need to choose how you're assessing that entry of CO2 in or out of the atmosphere, on what type of spatial scale and what type of temporal scale. And then you also need to start to disaggregate between different types of biomass and different land management practices, different economic systems, different market mechanisms that will influence the dynamics of how emissions get sequestered and emitted over time. And so it ends up being a relatively complex modeling process to actually try to answer this question, and that's the process that EPA has been navigating now for almost 10 years. So, and it gets a little circuitous here. 7 with the endangerment finding of Massachusetts versus EPA, where EPA determined that they were able to regulate CO2 under the Clean Air Act based on its harm to human health. And then in 2011, EPA issued a rule that would allow them to regulate greenhouse gas emissions somewhat differently from other criteria pollutants, to make sure that the regulations are manageable, that they're not regulating facilities that are too small. And then shortly afterward, they decided that they wanted to make sure biogenic emissions coming from biomass combustion were handled separately from fossil fuel emissions. So they issued a deferral rule on the back of the tailoring rule to say we want to have 3 years to figure out how to handle emissions from biomass. And following that, they initiated this process to develop their biogenic emissions accounting framework. At this, right around this same time, a court case from the deferral rule, who were arguing that EPA was not following the appropriate process for how to manage biogenic emissions. I think there was a concern from the environmental community that too much leniency was being given to emissions, and there was an expectation that there would be scientific rigor around how do you account for those emissions. During that whole time, the court case continued. EPA presented their first draft of the Biogenic Emissions Accounting Framework to their Science Advisory Board. In 2012, the Science Advisory Board issued a number of concerns about the framework, and very shortly thereafter, the DC Circuit invalidated the deferral rule. So in that 2013-2014 period, there was a lot of confusion about how exactly were bioenergy-related emissions being handled. At the time, there weren't a lot of regulation in place that would make that an issue for concern, but nevertheless, it ended up being a place where bioenergy emissions were, in theory, being handled the same way as fossil fuel emissions. EPA issued their new draft framework for biogenic emissions accounting in 2014. Late board spent pretty much the whole year of 2015 to review that framework. We'll talk more about that process in a little bit. And then just, what was it, last week, maybe 2 weeks ago, they finally issued an updated response to the framework. And now we're in a place where EPA is going to once again take back the input of the Science Advisory Board and how they're planning to handle the finalization of the framework, how they intend to integrate it somehow into whether the Clean Power Plan or other regulations. That is a very uncertain process, at least for me. Maybe other folks have some clarity on that. And I know at the very least Peter was on the Science Advisory Board panel discussing this. He can keep me honest about all of this. But we'll jump into this whole Science Advisory Board process that happened over this past year. So this equation was they was proposing in their 2014 version of the framework, and their intent was to develop these bioemissions assessment factors, BAFs, to evaluate biogenic CO2 emissions from stationary sources that use biogenic feedstocks. Give material to sequester CO2 over relatively short time frames. So that's actually a very important issue to recognize. The reason that we account for bioenergy differently than fossil fuels is not because at the smokestack there's significantly different levels of CO2. CO2 is emitted at the smokestack, whether you're burning biomass or fossil fuels. However, the life cycle temporal factor around the use of biomass makes it a potentially interesting mitigation strategy. You're utilizing a carbon source that can cycle more quickly in and out of the atmosphere, as opposed to being a net addition to the short-lived carbon cycle between living biomass and the atmosphere, which is what fossil fuels do. So we can go into each of these factors in the equation. I don't want to spend too much time because away from this equation relatively substantially, but it's a pretty simple framework from the beginning. Essentially, what the BAF is meant to indicate is the portion of emissions coming out of the smokestack from burning bioenergy that should ultimately be attributed to that bioenergy. So it's a unitless number between, well, it could be down to -1, it could be up to +1. I guess in theory it could be larger, but it's in either direction. But it is unitless, and it's meant to represent, for example, say you have a 0.5 BAF for a given biomass feedstock. That means that half of the emissions that get emitted from the smokestack are essentially counted as net emissions to the atmosphere. So if you have a negative BAF, that means you have a net positive impact on the atmosphere. That means, this is always tricky when you're trying to talk about direction and positive versus negative. A negative BAF means then you're emitting through the combustion of the biomass. And we can talk about different scenarios for how that might happen. So you need to take into account, obviously, the net growth of the biogenic feedstock on that landscape. You need to look at the emissions that would have been avoided if that, for example, if you're using residues from forest management that would have otherwise been burned on the side of the road. You can account for the fact that you're avoiding those emissions by utilizing it in a bioenergy facility. Then you want to understand other changes in carbon pools on the landscape where that feedstock was removed. For example, if you have a growing soil carbon pool, you want to understand that if you're using some sort of grasses for your biomass feedstock. For leakage, you need to understand whether creating markets for the type of biomass you're using is creating a higher price for that feedstock, and that way impacting alternative markets for that feedstock, and how does that end up impacting land management elsewhere. You need to account for any losses of biomass between where you've removed it from the land and its final use, whether that's through transportation or anything else. And then if there's any portion of the feedstock that ends up in, especially in long-lived products, then you can take that out of the stream. But essentially, this is EPA's proposal from 2014. Once again, the Science Advisory Board came back and had a number of proposed first of all, just quickly what EPA did change between their 2011 and 2014 frameworks. They took up the Science Advisory Board's recommendation to look at alternative fates of feedstocks, and also understanding relying more heavily on business as usual versus not a reference point. Oh my gosh, why am I blanking on how they termed this? What's not the reference point scenario. I'm sorry, I'm totally losing track. Anyway, we'll leave it at the alternative fate approach. I'll come back to this in a subsequent slide. But also EPA updated a discussion around trade-offs using different time scales for their analysis. They also developed feedstocks and regions, which was recommended in order to account for those differences, looking at ways to address leakage, and offering approaches to construct anticipated baseline. Sorry, it was right on this slide. Yeah, the anticipated baseline issue. Instead of comparing what the landscape looked like under a bioenergy use scenario to a certain time in the past, you would be comparing your bioenergy use scenario to an anticipated non-bioenergy using scenario, so that you're basically projecting into the future two different scenarios. And you can see that is what that's what the SAB, the Science Advisory Board, looks at very carefully in their recommended changes. The SAB recognized that EPA had made a number of these important updates in the 2014 version of the framework. That was all good, but still they had a number of changes that they recommended to the framework. A lot of them I think are very strong and probably will greatly improve the framework. We'll walk through a couple of these and provide some examples, but the main takeaways if I've left anything out. I think the main recommended changes to the framework that were released in the Science Advisory Board response just a couple weeks ago were that, what order did I put these in? So that you want to take into account the fact that emissions emitted or sequestered over the entire lifetime of your policy trajectory or your terrestrial carbon changes, you need to take those things into account cumulatively, and we'll talk about how SAB indicated that should be done. They came out with a very strong recommendation that the best way to account for the net emissions impacts of bioenergy use was to look at the entire time period along which changes on the landscape would occur. So they rejected this idea of a policy horizon where you create a shorter time. You might say, well, we're only going to look at the net emissions impacts after 20 years. That's what some environmental groups were advocating, to use very short times impacts. And my reading is that the SAB very strongly indicated that you should use as long a time scale as needed to understand what those net impacts are, and particularly because in terms of what's important to the climate or what's important to the atmosphere, really the cumulative emissions impacts are what's most important, not necessarily the pathway for how you get to the endpoint. They propose an alternative calculation method, contrary to the equation I walked you through. They have an alternative carbon pool approach for how they'd like to see that done. They suggested that EPA undertake a process for looking at the sensitivity of their results based on their model assumptions. EPA used a pretty big, complex model called FASM to generate their BAF numbers in the 2014 framework, and the SAB wanted to see how would different model scenarios, are you justifying the assumptions that you're using? And with a big model like FASM, I think that's probably a very good process to undertake. And then the SAB also indicated that it's probably important to be able to go back and update your BAFs that you calculate because they're so heavily based on projections. You want to make sure that they are actually reflecting reality and that there's a way to appropriately calibrate these calculations over time. So really quickly, and I want to be able to open it up for some discussion in a little bit, but here's some examples from the final SAB response to the framework. This is their the basic. Let me see if I can get my pointer out. The basic equation for how you're calculating the BAF stays the same compared to what EPA was proposing. Basically, the BAF is your unit of the total possible carbon emitted from utilizing that biomass. That's essentially all the carbon in the biomass that you're utilizing, and then this fact carbon that ends up being that is the net amount of carbon that is being emitted. Yes, that's the net amount of carbon that would be emitted. Someone correct me if I'm wrong on that. I always get that confused. Yes, but it should be higher for biomass sources that are using that are ultimately, you know, not that great compared to fossil fuels. This is going to be higher. but how they are calculating this top factor is quite a lot different from what EPA was proposing. They're essentially using more well-established carbon pools, live carbon, dead carbon, soil carbon, products, wastes, and transportation losses, which the SAB argues is more in line with data that's already collected and with the approaches that are used in research right now. How exactly this changes the analytical results is not clear to me, at least, but it could just be a simplifying approach community to engage in this process. Now, the alternative handling of time issue is quite interesting because it does have an impact on how BAFs get assigned to various biomass feedstocks. What they're proposing here is that instead of what EPA was proposing, which is to understand your net emissions impact, you would be looking at the difference between, for example, your land carbon stock. Let's say we're looking 30 years after a certain policy has been implemented to incentivize bioenergy use. After 30 years, we look at what's the current land carbon stock, what does it look like under that policy scenario, and what do we think it would look like if we hadn't used all of that bioenergy, how much land carbon would we have? Under EPA's approach, you would only be comparing those land carbon stock values in year 30. But what the SAB is proposing, that instead of in time, for example, here, it's year 90, instead of only looking at the change in that single point in time, you actually want to look at the entire time scale and the emissions dynamics over that entire period, so that you actually have a better sense of the cumulative atmospheric impacts of any carbon that's been lost or gained to the atmosphere. And just to this figure, this is a little bit of a dense figure. I gave myself some notes to cheat a little bit, but probably the easiest line to understand is this red BAF delta T. That's pretty simplistic, reflects the year-to-year difference between emissions of using, for example, 1 ton of biomass for bioenergy each year. It reflects the difference between your emissions and your land carbon sequestration each year. And so you can see over time, by year 90, you hit a new equilibrium state where you're no longer emitting more to the atmosphere than what you're sequestering. So if you use this approach, the delta T approach, over time you would have a different BAF essentially every year. Now, what the SAB panel is proposing is to use this dotted circle line here, which essentially is summing all of those differences time between your net emissions from your biomass usage and your land carbon sequestration, so that it's a little bit more of a weighted average between your beginning and your end. So you're in this instance, you're having to account more for all those emissions that are still likely in the atmosphere. So you can see what EPA was actually proposing was kind of a middle ground between those two things. They were proposing a running average of this line, which is more or less this. This line is a running average of this. What this line does is it actually accumulates all of these emissions and takes that average over time. So it requires you to take responsibility for emissions that happened in the past, and so you can see it's actually higher. Using that cumulative approach that the SAB is proposing puts you in a higher, this biomass is essentially, it's representing that it has higher emissions than if you approach that EPA was using. I know that's a little complicated, so we can talk about that. And I also, for anyone, Peter, anybody who's really deeply engaged in this, I'd love to get your grade on how I'm explaining this. I hope I'm doing it justice. But there's different scenarios here. This is a scenario where, for example, you have a net increase of emissions to the atmosphere. This could be an example of increased thinning in forests, where you have a very clear reduction of carbon in the forest at the beginning. It's not prescribed what exactly this is an example of. This is a net positive increase of emissions to the atmosphere. But you could equally have a situation where this could, for example, be a scenario where you've planted a bunch of perennial grasses and you want to use that in a biomass co-firing scenario. Maybe you want to torrefy the grasses and use them in a coal plant. But there's this bump down that could represent your soil carbon sequestration from the grasses. And the same thing, if you're using this red line year-on-year approach, eventually you reach this new steady state where you're back at zero, and you wouldn't be getting any credit for all of the carbon that you sequestered back in the early years. But under the SAB's proposed approach, because it's more cumulative, you get that bump at the end. When you've reached your steady state, you get credit for all of those emissions that are still sequestered underground, for example, if this is a perennial grass example. So just a really quick couple key takeaways for me from reading the SAB final report. This was a very strong statement in my mind. The kind of statement that was probably one of the reasons why it took them a while to issue the report. So long as biomass is regrown repeatedly and appropriately substituted for fossil fuels over successive harvest cycles, the use of biomass for energy need not imply greater net greenhouse gas emissions at longer timescales compared to a business as usual scenario. This is one of the reasons why they think using the time period over which all terrestrial effects occur, whether that's 80, 90, 100 years, I think this was a very strong statement, and for folks in the biomass industry, especially in the long-lived biomass sectors, this is a very supportive statement for the fact that long-lived feedstocks can have positive effects for mitigating climate change. And they also go on to say that it's a little bit of a red herring to say that the best possible mitigation strategy for forests is just to leave them any carbon that's sequestered in soils or in trees. It's not right to consider that a permanent mitigation strategy. It doesn't occur automatically or permanently. And that all of these, these are all management strategies for these landscapes, and they all need to be evaluated. And there can be different approaches for mitigating carbon with bioenergy as well. And then there's also a number of areas where EPA is still going to have to make decisions, and as they finalize this framework, there's still a lot of issues that are not yet finalized, like selecting appropriate temporal and spatial scales, considering variability within classes of feedstocks, and accounting for non-CO2 greenhouse gases. So these are just one of many things that EPA is going to have to think about as they try to take back what the SAB has given them and think about how to manage this under the regulatory schemes. All of this being said, this kind of complex, very thoughtful, quantitative strategy for handling bioenergy is very different from what a number of folks in the on the industry side have been proposing. There's been a lot of recommendations, especially through Congress, to consider bioenergy as net zero carbon across the board. Their latest effort, 3140, the industry folks tend to also indicate that bioenergy should only be considered a net positive source of emissions if national land carbon stock begins to decrease. They've been very strong responding to EPA's final Clean Power Plan rule, which says qualified biomass will have some sort of ties to sustainably managed landscapes. They want to make sure that the industry folks want to make sure that sustainability in this context only refers to carbon and doesn't start to seep into other components of land management, other aspects of how landscapes are managed. And they also, other industry recommendations have been not to disaggregate by feedstock and keep everything in the same pot. And a lot of this is just interest in minimizing regulatory complexity, which is of course understandable from an industry perspective. And a lot of this ends up being most controversial around the issue of Roundwood. Those debates continuing have been continuing for years. So just to close out, EPA, as they finalize this framework, is going to have to do a very careful balancing act. And this is really the hardest part of their whole process here, is that they need to meet their legal constraints and things that they've had to face in the past with the deferral rule and the district court in needing to demonstrate that the approach for handling bioenergy is scientifically sound. I think that was a large reason behind the whole Science Advisory Board process, so that they have something that's vetted by the scientific community. But now we've also ended up with a framework that's actually pretty cumbersome and complex. There's only a handful of people around the country that are able to manipulate the model that EPA is using to calculate the BAFs at this stage. So unfortunately, it's on a bit of a spectrum between a finalized approach that's legally and scientifically sound, and also something that's flexible and feasible for states to take up, and for individual landowners and individual power facilities to be able to make sense of it, to understand whether they're using the right kinds of biomass or what kind of risks they're taking in using certain types of biomass. So that's the real challenge for EPA, and I think that's what they're going to want to hear in their April 7th workshop that Sarah mentioned at the beginning. They're trying to figure out what is the middle ground here that will check all the boxes, minimize their legal risk, and also something that's actually usable by stakeholders. So here we are. I think that's it. And for me, this whole definition of qualified biomass and how the biogenic emissions framework plays a role in that is probably one of the most, if not the most important issues facing in the U.S.
Great. Thank you so much, Emily.
Today.
To all of our participants, please type
So I'll
any
stop
questions you have in the chat pod. We'll start off with a few that have already been asked. Chuck asks about the status of the energy bill that you mentioned that would really greatly simplify this process, perhaps too much, some might argue. Do you think that's something that's likely to pass?
So yeah, the challenge with the energy bill is all the amendments that have now been proposed has made it very cumbersome. I am not conversations, but my understanding is that there's much less optimism at this stage around the energy bill moving forward than maybe a month ago. I know there's still a lot of discussion and hope from the co-signers that it'll move forward, but there might be folks on the call who understand that better than I do.
I mean, you mentioned in your last slide, I'm going to flip back to it really quickly, the need for an EPA approach that lands somewhere between, somewhere on the spectrum in the middle. So there's a question from Jesse, do you expect that the SAB will impact, the outcomes of the SAB deliberations are going to impact EPA policy for state plans? So ultimately, state area regulators are going to, if they're wanting to do biomass, are going to need to create some kind of accounting scheme or a recommended list of biomass feedstocks to be used in their plans. If this approach is a little bit above the expertise of those individuals, is there room for something, some kind of facilitated partnership between the EPA and those individual state regulators to perhaps create a regional BAF list of feedstocks that have been submitted in one of the early plans that are sort of ground truthed through this modeling process at the higher level by the EPA, so that those can ultimately be used as something like an approved feedstock list, which we've heard floated as an idea in the past?
Things are headed. The devil is obviously in the details of how you develop that list and how finely you disaggregate various feedstocks and how you are able to add to that list over time. Does it become something like the process for adding new fuel pathways under the renewable fuel standard, which at this point takes a tremendous amount of time and is one of the larger challenges to investment in new fuel pathways, but I think generally that's probably right. That's probably the way this is going to have to go, because that's one of the only approaches I can see of how you land in the middle here.
So you would say that,
but I think EPA is looking for creative ideas at this stage.
Okay,
I would guess.
So you would probably think that an approved feedstock list approach for the CPP and other policies in the future is probably likely?
Sorry, say the first part again.
I'm sort of titling what I stocks approach, where you have a list of approved feedstocks to be used for the CPP or future policies. So you would consider that a likely approach?
Right. I mean, I think, headline, yes, I think that's a likely approach. What exactly that means, I think, is probably the real is the real trick, and the details of that are going to be complicated.
Sure. If you wouldn't mind humoring me as we kind of go down this. I mean, let's talk just about the CPP specifically. Do you think that is probably a model that would be best served at the state level, or as a regional approach where you might have groups of states coming together to submit a recommended feedstock list and go through that approval, where sort of regional EPA analysts can look over those things?
Well, right now, it's a state by state. EPA has already indicated that each state has flexibility to implement this type of framework as they see fit, as long as it meets their list of criteria that they've laid out for what qualified biomass So anyway, I was just going to compare, if it would be good to avoid a situation like where we had, like in Europe, where essentially every country has a different biomass sustainability and emissions accounting approach, which ends up being pretty cumbersome for the industry. It would be great to avoid something like that in the US, but it would require some coordination across the states.
Speaking of cumbersome and trouble, Chuck, about verification and evaluation metrics. What's the approach going to be for that when it comes to, I guess, not only checking the proposed use of biomass, but also the realistic, actual resulting use of biomass through, let's just take, for example, co-firing, since you mentioned it earlier.
Well, just trying to read Chuck's questions as you were talking about it. I'm most familiar with the European approach, the chain of custody approaches that they use there, which is mostly it's a mass balance approach. You're tracking flows of biomass essentially on a ton-by-ton basis, but you don't know the particular ton that you have at any one moment is a discrete ton. You just know that in the system there are tons that have this characteristic of sustainability.
I see. All right. I'm going to ask you, this is might be a little bit outside the scope of this Q&A period, but as we talked about equation and the BAF calculations, I was wondering if you could talk us through one feedstock example that was evaluated in this way, taken through this calculation framework, and ultimately ruled on as either carbon negative or carbon positive. Could you talk us through such an example?
Well, I don't know if I'm not understanding the question. I don't process here. Do you mean give an example of an analysis that EPA did to generate a BAF, to generate a BAF number?
Yeah, for a given feedstock, what might this graphic representation show? I mean, what system might this represent?
Whew, that's a hard question. So you mean for this figure in particular, this one that's up here?
Yeah, this one or the one next to it. So I mean, I think you gave a couple of examples, but assuming that each feedstock would have to be evaluated on a similar approach, I was wondering if you could sort of talk through these graphics in terms of what feedstock they could hypothetically represent given what they look like in your expertise. And if that's outside sort of the scope of what you want to speak to today, that's fine, we can move on, but I think it would be helpful to go through that.
Sure. Yeah, and I think I tried a little bit to do that maybe with these figures, and maybe you can tell me where some additional detail would be useful. Was that it could represent a situation where, for example, you have just, for example, let's say every year you're harvesting an additional acre of mature plantation loblolly pine to supply a nearby coal plant, and you wouldn't do that because the value of that material is too high for use in the power sector. But that's, that could be it. Or let's say this represents slightly more realistic scenario if it's an additional round of thinning for a particular acre that maybe didn't economically make sense before. So you're thinning, year 8, and every year. This doesn't just represent, one 1 year of increased harvesting. It's meant to indicate a new annual increase in demand for, let's say pre-commercial thinning. And so what happens in year one, spike of, in theory, net emissions to the atmosphere, which is eventually decreases over time because you ultimately start to, let me try to bring the pointer out, you ultimately begin to make up that debt of emissions to the atmosphere because you've been offsetting fossil fuels that would otherwise represent a permanent increase of emissions to the atmosphere. So what this decreasing line represents is that pathway to getting to carbon neutrality through that, one additional year of thinning, or, that that does represent some net emissions in the beginning of the timeline, but then you're offsetting fossil fuels, and at the same time reharvesting and rethinning, so that over time your net emissions to the atmosphere go back down to zero. Now, what these other lines represent is that in that thinning and harvesting process, yes, that's happening on an annualized basis, but you need to account for that initial spike of emissions that may not yet have been totally compensated for and resequestered in that process. And so what would need to happen, for example, is to bring this line all the way back down to zero, is that in these out years, you would need to start to, for example, afforest in other areas so that you have, net sequestration in the long run. Does that help at all? Does that answer the question?
Yes. Yes, it does. So it seems like this approach, rather than a sort of individual case approach where we think of management at the stand level, for example.
Right. I mean, I used kind of a very small scale example, but in theory, the best way to look at this is from either a regional or a national approach, so that you're accounting for all the complexity of how emissions are entering and exiting, land-based carbon, and so you're able to account for leakage. For example, if those trees that you are thinning are were originally going to a local pulp mill for paper, and you taking them away from that and using it for bioenergy causes thinning to happen elsewhere at a more rapid pace. You have to take into account the leakage into and impacts on other markets to understand the total net impact on the landscape. And in order to do that, you want to have a pretty large spatial area for consideration. But yeah, I mean, these are all the things that ideally you'd be taking into account.
It's very easy to understand how complex then this framework really is, and why it's, within the expertise perhaps of just a few experts. When you explain even a simplistic example with this many pieces, uncertainties associated with it. So you mentioned the need for some calibration of these calculations to better insert uncertainty or sensitivity analysis for policy scenarios. I'm curious if you could speak to what data are needed for that type of approach. Are these major data sources already being collected? On what timescale? I mean, have we been collecting those over time? Can we sort of model those into the future accurately? I know that's a big question. You can sort of take any.
Yeah, that slide that I maybe tried to talk about that. that is a very, I would say in the research community, that's a pretty controversial question. For me, if I had to say the most important information that we could bring to the table in this whole analysis, it would be understanding landowner responses to market signals for bioenergy. How do various levels of landowner management choices change based on different levels of payment for biomass that would end up in bioenergy sectors, and how long of a time period are those landowners planning over? Because one of the big assumptions that what they call anticipatory planting, where it's an economic optimization model that assumes that landowners have perfect foresight over the long term and can basically detect that bioenergy will be a valuable market, and that they will plan they will manage their landscapes in a way to provide for those bioenergy markets over time, and so that you see this growing of forestry material. In the model, you see this kind of very robust landowner response to a assumed growing bioenergy market. But does that reflect what would really happen? Would the landowners really be planning on the kinds of long time horizons that the model assumes? At what price levels would be meaningful to the landowners to undertake those kinds of anticipatory actions? I'm getting into things that are pretty who would be able to speak to these kinds of things. But in my mind, that's one of the bigger issues that would need to be addressed. A lot of data out there that supports some of the assumptions that are being made in the models.
Yeah, I definitely agree with you. It's a really key human dimensions research need, and definitely changes a lot based on the regional makeup of not just forest type, but the demographics of landowners as well. And yeah, I think that's a really key point, and I'm glad you brought that up. I have one last question for you, and if any of our participants have final questions, please type them in now. My last question for you is, there's continual reference throughout this presentation on the importance of looking at timescales beyond the policy life, looking at them on the timescale of the terrestrial system in place. But in a couple of the examples you gave in those graphics, they showed maybe 100-year timescale. Just maybe that was only what was projected for the sake of this presentation. But I think it's still a little ambiguous from what you talked about what an appropriate we should be looking at is. I mean, is it like 100 years? Is it 1,000 years? Is it a geologic time scale because we're looking at a fossil fuel alternative? I think it's still a little bit unclear to me what the recommended time scale we should be thinking about as we handle these questions should be.
Well, I think the SAB was pretty clear that it needs to be whatever time scale is able to take into account all the terrestrial changes that occur based on a given policy. In terms of how that translates into how many years is that, that's going to depend on what kind of impact the policy has and what kind of scale of demand it's creating. You could imagine that a policy that's having a very large impact on biomass demand is going to take longer to resolve all of the terrestrial impacts that happen there. and a not as impactful policy, that's not going to you'll reach your new equilibrium state relatively quickly under that scenario. What do I think that means for the Clean Power Plan? I think 100-year timeline is probably the right order of magnitude. At least several decades to, in terms of the amount of biomass that's likely to be used under the Clean Power Plan. I don't think it's going to totally revolutionize the whole, the biomass sector. I think it will become likely a growing be some examples where grasses are used, maybe torrefied in certain instances, and that you might be looking at a couple decades over which the impacts of that policy play out in terms of on the landscape.
All right, thank you so much. I know we're over time. We just have had some really great conversations in this series so far and a lot of good questions, so I wanted to keep you here as long as we reasonably could. I want to thank you again, and Emily, I'm going to ask you if there are any final thoughts you want to leave us with, but as you think about that, I just want to remind all of our participants that all of these sessions are recorded, and you can find the recordings along with the slides through our series website, which you saw linked in the chat pod on the left, and will accompany the recordings in the bottom of the YouTube recordings there. It should be up sometime later today, or at the latest sometime tomorrow. So I want to thank everyone for joining us today. And Emily, are there any sort of last-minute thoughts you want to leave us with as a final message from your presentation?
No, I probably talked enough. Just thanks a lot, everybody, for taking the time, and really great questions. I hope I helped rather than created more confusion.
Not at all. Thank you so much, Emily. This is a great job on a big, messy topic. There's certainly a lot to be discussed, and we really appreciate your expertise, and we want to thank you. We know the value of your time, and we're very glad that you were able to join us today and speak on some of these messy topics. So thank you again, Emily.
Thanks, everybody.